Assalamu alaikum wa rahmatullah. Hello everyone. In this video we will work on question 4 from the coverage of grade 11 elite for term 3. So this file has two suggested questions. This is the first one. So we have a function f of x given by the graph. Okay, so the continuous function f is defined on the closed interval from -5 to 5. The graph of f consists of a parabola and two line segments as shown in the figure above. Let g be a function such that g prime of x equals f of x. So the question says that the function f is continuous. Before we start doing the question, we must understand what's going on. It's defined on the closed interval from -5 to 5. Okay, it has a parabola and two line segments as shown in the figure. And also there is another function called g. It's defined as g prime of x is the same as f of x. Yani, this is the graph of f, and at the same time it is the graph of g prime of x. We really need to understand this. This is the graph of f and the graph of g prime of x at the same time. Part A, fill in the missing entries in the table below to describe the behavior of f prime and f double prime. Indicate positive, negative, 0, and we have to give a reason for that. So they are asking us to complete this table. Now we need to find f prime of x. What is the sign of f prime of x? Or is it 0 from -5 to negative? From -5 to -3. So from -5 to -3, the function f is increasing, right? F is increasing. And if something is increasing, its derivative will be positive. So I'm just going to indicate positive, okay? Now, from -3 to -1, from -3 to -1, if you notice, if you look at this portion, it is decreasing. That means the derivative will be negative. And then after that, from -1 all the way to 2, it's going up. That means it's positive. And from 2 to 5, f is going down. That means it is decreasing. That means the derivative will be negative, okay? Let's write a reason for that. Well, for -5 to -3, and also from -1 to 2, f prime is positive because f is increasing. Understood? F prime is positive because f is increasing, right? Okay, similarly, we can say that for the other two intervals highlighted in green, f prime is negative because f is decreasing. So we can write it somewhere here. Let me just get a space. Okay, for negative, for this interval and the other one 2 to 5, f prime is negative because what? F is decreasing. Oops. Well, no, this is the question 5. We are here because f is decreasing. Okay, just decrease. Plus it's decreasing. Okay. Now, what about f double prime? Well, f double prime of x. Okay, so notice that we have a linear function from -5 to -3. This is a linear function. The derivative will be constant. The first derivative will be constant, but the second derivative will be 0. And the last piece, from 2 to 5, the function is linear. The first derivative is constant, the second derivative is also 0. Okay? Now, between minus 3 and minus 1, from minus 3 to minus 1, and also from minus 1 to 2, the second derivative is going to be positive. Why positive? Because the function is concave up. If you look at the graph, it's concave up, right? If it's concave up, then the second derivative will be positive. So where do we write those two reasons? Okay, from negative 5 sorry, to minus 3, and from 2 to 5, f double prime is 0 because f is linear. F is linear there, right? Okay. So the second reason is going to be why did we choose positive? We can write the reason here. From minus 3 to minus 1, and from minus 1 to 2, f is concave up. That's why f double prime is positive. So please, when you if a similar question appears in the exam and you are completing the table, after completing the table, please mention these reasons. Okay, this one, this is the first reason, and then this is the second one, and this is another reason here. So please mention those reasons. Okay, these are the 4 reasons for the table. Okay, so the second part says there is no value of x in the open interval from negative 1 to 5 at which f prime of x equals f of 5 minus f of minus 1 over 5 minus negative 1. Explain why this does not violate the mean value theorem. Now, if you look at this theorem, this is the mean value theorem. The average rate of a change equals the instantaneous rate of a change. F prime of x is the instantaneous, and the second side is the right hand side. It is the average rate of change between negative 5 and 1. So here in this part, the mean value theorem does not apply because the function has to be continuous and differentiable. But if you look at x equals 2, there is a sharp corner where f is not differentiable at x equals 2 due to a sharp corner. So this does not violate the mean value theorem because, so we can say that for part B, the mean value theorem, MVT, does not apply on the given interval, on the interval. What's the given interval? From negative 1 to 5. Why? Because we said f is not differentiable, right? F is not differentiable when it's not differentiable at x equals 2 due to a sharp corner. So this doesn't violate the mean value theorem, right? Okay, here there is a sharp corner at x equals 2. Okay, so looking at part C says, let's do part C here. 1 second. It says find all values of x in the open interval from -5 to 5 at which the graph of g, this is very important, the graph of g has a point of inflection, not the graph of f, the graph of g. Explain your reasoning. So we said this is the graph of g prime of x, right? This is the graph of g prime of x. So here g prime is increasing, right? That means g double prime is positive, right? And beyond this point, what happens here in this interval? I'm going to write it here. G prime is decreasing. That means g double prime is negative. So what happens at -3? G double prime changes sign. So this happens at x equals -3, right? It happens also at x equals -1. It happens also at x equals 2. Because at all of these points, g prime of x changes from increasing to decreasing or decreasing to increasing. That's why there are 3 inflection points for the graph of G, not the graph of F. Be careful. Okay, so the last part, D, at what value of x does G attain its absolute maximum on the closed interval? Absolute maximum on the closed interval. And we're talking about G, right? We are talking about G, okay? So this is very, very simple, this part. We can see that this happens at the right endpoint, right? Because G prime of x is positive from -5 all the way to 5, right? So if we answer part D here, we see that G prime of x is positive, yani greater than 0 on which interval? On the whole interval, on the interval from -5 all the way to 5, right? So that means what happens if G prime of x is bigger than 0, yani positive above the x-axis? That means G of x is increasing. It's increasing on the same interval from -5 to 5. So here from this is -5 and this is 5 and G is increasing. That means the absolute minimum happens at x equals -5. This is the ABS, absolute minimum, at the right end point. Sorry, it's not, it's yeah. Is it asking about the minimum or maximum? Sorry, that's my bad. It's asking about the absolute maximum. The absolute maximum happens here. This is the absolute maximum at the right end point at x equals 5. Hopefully this was clear. Good luck.